All right, today on topic 7.6, we're going to learn kind of the how we get back to a particular solution, all right? And separation of variables is a very important skill in AP Calculus. And so on these examples, they're going to say, find the general solution. All right, and when we see the word general, that's different than particular. All right, when we see a general solution, we know that there is going to be a plus C on the end of it. We don't have enough information to find out what that C value is. All right, so let's get started with this. We're going to start with a very basic one, dy dx equals y sine of x. Now, look at the title of what we're learning today. Separation of variables means that we need to separate the variables. We need the y's on one side and the x's on the other, algebraically, before we ever start. So, watch what we do. First thing is, this dy dx, this differential, I can think of as a true fraction. So the first thing I can do is I can multiply both sides by dx. If I multiply dy dx by dx over 1, the dx's cancel. And so on this side, I'm also going to multiply it by dx. Now, eventually you can get to the point you can do that mentally. That doesn't require a separate step. I'm just explaining to you how we got there. I also need to move this y over here using a true algebra step. So I would divide both sides by y now. And what I have now is 1 over y dy equal to sine x dx. And at this point, my variables are separated. Okay, very important to note that at this point the variables are separated. That can cost you a point or two on the end of course or on the extended response section of our AP exam. It could also gain you a couple points just for doing that correctly. All right, so it's important to know how to separate variables. At this point, we're now going to integrate, make a note here, variables are separated. Very important that we know how to separate variables. You will like these problems because they're really just a lot of good old-fashioned integration and algebra. All right? At this point, I am now going to integrate both sides. What I do to one side, I do to the other. So I'm integrating the left side, I'm integrating the right side. And this is a nice, fairly easy problem to start with, but it's going to help you get the idea. So, on the left side, we recognize this, the antiderivative of this is the natural log. So, on the left side, we're going to have the natural log of y. And no, we do not have to put a plus c on the y side. We only put it on the x side. And that is equal to the negative cosine of x, and then I have my plus c. Now, this is technically a correct antiderivative, but I have not found the general solution until I solve it for y. So I need to now solve this for y. And you probably need a reminder on this, but all of you should know what to do here. What we're going to do is we're going to exponentiate both sides. We're going to raise this as a power of e on both sides. And what that's going to do on the left-hand side is it's going to get our y by itself. All right? So on the left-hand side, e to the natural log of the mess is just the mess. So that gets my y by itself. And on the right side, we're kind of done, but we're kind of not. All right, let me show you what we need to do to clean this up. This is the same thing as e to the negative cosine of x times e to the c. Remember, we add exponents, all right, when we multiply with like bases. And what we do in calculus is we say that this value right here is just a constant. So we call it c, and it's being multiplied by e to the negative cosine of x. And now we have a general solution. And you could put the c out in front if you like it better out in front. You could write it like this if you wanted to. And that's our general solution to number 1. And we will move on to our next problem. Let's look at another one. This one has a little bit more work just to get things separated, which is why I'm doing this one. dy dx equals 3e to the 2x plus 5y. So our first thing is to separate variables. Well, they've got this messy exponential thing, but if we know our rules of exponents, this isn't that bad. This is the same thing as dy dx equals 3e to the 2x, all right, times e to the 5y. All right? And that's maybe one of the most important steps of the whole problem, is knowing that we can do that. Because now we can start, I can multiply both sides by dx. All right, and I told you can do that mentally if you want. dy equals 3e to the 2x e to the 5y times dx. And if I want to get my y's together, I need to divide both sides by this. So now I have 1 over, I would have 1 over e to the 5y over here, but I'm going to go ahead and write it as e to the negative 5y dy equals 3e to the 2x dx. And our integration here on both sides involves a substitution. We're going to need to integrate both sides, all right, and integrate this side, integrate this side, all right. So on the left-hand side, I would let u equal negative 5y, so my du is negative 5 dy. I need to introduce a negative 1/5. On the right side, I would let u equal 2x, du equals 2 dx. I need to introduce a 1/2 over here. So I'm going to try to fit this all on the same page here. So on the left side, I've now got a negative 1/5 times the integral of e to the u du. On the right side, remember that I had this 3 here, so I don't just have a 3 out in front, I've got a 1/2 out in front, so I have 3/2 times the integral of e to the u du. Okay? Now I'm finally ready to move on. I've got negative 1/5 e to my, let's put my u back in, negative 5y. Over here I've got 3/2 e to the 2x plus c. And what I would do next is remember what we're trying to do now. We're trying to solve for y. I'd multiply both sides by -5. So I now have e to the -5y equals -15/2. All right. E to the 2x plus c. And algebraically, what do you think we should do? We're trying to get y by itself. I've got this e over here. It makes sense to take the natural log of both sides. Take the natural log of this side. Take the natural log of this side. I'll just put that for now. On the left-hand side, we get our -5y. On our right-hand side, we have the natural log of this mess. And then I multiply both sides, or divide both sides by -5. So y equals -1/5 times the natural log of that mess, this thing up here. All right. And that is a general solution. Like it or not, that's a general solution. Okay? Let's take a look at one more. dy dx equals cosine of 3x over the sine of 4y. So again, we've got some separation of variables stuff to do. And this one's actually kind of nice because you can just cross multiply. If you cross multiply, you get your variables separated. You can't always do that, but on this one you can. If I cross multiply, then I have sine of 4y dy equals cosine of 3x dx. All right? And so I'm not going to spend a bunch of time. You see that we're going to integrate both sides. All right? And we're going to have a u here. What's my u? My u is 4y. My du is 4. So I need to introduce a 1/4 out in front of here. Over here, it's going to be similar. I'm going to need to introduce a 1/3 cosine of u, du. All right, just to kind of speed things up here a little bit. Get my integral symbol in there. And so my antiderivative on this side is the -1/4 of the cosine of my u value, which was 4y. On this side, it's 1/3 times the cosine of 3x plus c. The reason I'm doing this problem is because I wanted to remind you how in the world am I going to solve for y on this problem. Well, I'd multiply both sides by -4. So I have the cosine of 4y equals -4/3 cosine of 3x plus c. And if I wanted to solve this for y, I would need to take the inverse cosine of both sides. The inverse cosine. Okay? So we're going to take the inverse cosine of both sides and just caught over here on the right-hand side. This should be a sine. Sorry about that. So we're taking the inverse cosine of that whole crazy thing. And what that does on the left side over here, that leaves me with just a 4y. The inverse cosine of the cosine of something is just the argument. All right? So I have 4y equals this inverse cosine of this thing, and I divide both sides by 4, which is just like multiplying that thing by 1/4, and it's the inverse cosine of that whole mess. The negative, this mess right here. The negative 4/3 sine of 3x plus c. And we will stop there for today.